All right, you are welcome again. Today, let's talk about differential equation. In this topic, we're going to introduce this topic, differential equation. Let's see what it is, how to solve it, and then also the importance. So what is this differential equation all about? In mathematics, we call the changing entities variables. That is anything that can change. We call it a variable, okay? And then you know that as it can change, the rate of change of a variable with respect to another is what we call a derivatives. That is to say, two things are related, and these two things that are related, they do change. So one changes because of another. So the rate of change of one variable depending on another is what we call derivatives. Okay, now let's go. We say that any equation expressing a relationship among variables and their derivatives is what we know as differential equation. We started initially by explaining what variable is and what derivative is. Variable simply means anything that can change, changing entities. We say when we have changing variables, so the rate of change of one with respect to another is what we call derivatives. And then we say it again, that any equation expressing a relationship among variables and their derivatives is what we call differential equation. Okay, so in another word, differential equation originates whenever a universal law is expressed by means of variables and their derivatives. Okay, when a universal law is expressed by means of variables and their derivatives. Okay, now let's go. In a nutshell, or maybe in a simple language, we say that an equation which involves differential coefficient is called a differential equation. Now let's see, for instance, examples of differential equations, so that anywhere you see a differential equation, you'll be able to know that this is a differential equation and this is not a differential equation. Now let's see some of them. Actually, we are going to be working with so many of them. Okay, so you'll be conversant with them, you will know them, and you can even form your own differential equation. Okay, now let's see some of the examples. Number one, we have dy dx is equal to 1 plus x squared all over 1 minus y squared. This is an example of differential equation. Now the next one, we have d squared y all over dx squared, that is second derivatives, plus we have 2 dy all over dx minus 8y is equal to 0. This is another example of differential equation. So we have another one, dy all over dx equal to a sine x. We have another one, d squared y all over dx squared in bracket cube plus 2 dy dx equal to 0. Another one, we have the second partial derivatives minus x squared y equal to 0. This is also example of differential equation. Now the next one, we have x squared dy all over dx equal to y sine x. This is also another example of differential equation. Okay, another one, we have x y d squared y all over dx squared plus y dy all over dx plus exponential 3x, that is e raised to the power 3x equal to 0. So this is example of differential equation. Now let's talk about types of differential equation. We say there are many types of differential equation, but the common differential equations include: number one, ordinary differential equation. In abbreviation, we call it ODE, ordinary differential equation. And then number two, we have partial differential equation, or we simply say PDE, partial differential equation. Okay, now what does ordinary differential equation mean? We say that ordinary differential equation is an equation that contains one or several derivatives of an unknown function, which we usually call maybe a function. Okay, we have y of x. You get it? It's a function. Now we say it, for instance, we have dy over dx is equal to cos x. This is ordinary differential equation. We have the squared y all over dx squared plus 9y equal to 0. This is example of ordinary differential equation. Now let us see partial differential equation, so you'll be able to know the difference, okay, between ODE and PDE. Now when we talk about PDE, which is partial differential equation, we mean an equation involving one or more partial derivatives. Now look at this word. It involves one or more partial derivatives, okay, of an known or unknown function. We can say maybe u that depends on two or more variables, which oftentimes t and one or several variables. Now look at it very well here. We say that ordinary differential equation is an equation that contains one or several derivatives of an unknown function. Contains one or several derivatives of an unknown function. But when we talk about partial, so it involves one or more partial derivatives. So when you have a differential equation and the differential coefficient that you have there is partial derivatives, so we call it partial differential equation. When you have a differential equation and the differential coefficient is not partial derivatives, then you know that this is ordinary differential equation. But when you have a differential equation and the differential coefficient is partial derivatives, we call it partial differential equation. I think from this little explanation, you should be able to tell the difference between ordinary differential equation ODE and partial differential equation PDE. Okay, now let's go back to ODE. ODE may be divided into two large classes. It may be divided into two large classes. Number one, we have linear ordinary differential equation and non-linear ordinary differential equation. So you will know the difference between linear and non-linear by the definition of degree. Hello. Now, in polynomial, we deals with degree, right? So the degree, if the degree is 1, you say it is linear. If the degree is 2, you say that it is what? Quadratic. If it is 3, you say it is what? Cubic, and so on. Is that true? So likewise, when you come to differential equation, so the differential coefficient, what is the degree of that coefficient? If it is degree of 1, you know that it is linear. But once it's no longer 1, it is non-linear ordinary differential equation. You get it? So when you are able to tell the degree of any differential equation, you'll be able to know whether this differential equation in question is linear or non-linear. Okay, now let's talk about another aspect. Okay, now this is order and degree of a differential equation. Please, this order and degree is very important, okay, because you know a differential equation and you cannot tell the order and the degree. It's the same as you don't know anything about differential equation. Please pay attention. Let me show you what it means by order and then the degree of a differential equation. Now let's start. The order of a differential equation is the order of highest differential coefficient in the equation. The order of a differential equation is the order of highest differential coefficient in the equation. Okay, now let me explain this. When you have a differential equation, now what is the highest derivative involved? Hello, you have a differential equation, you get it? And okay, for instance, when we are listing examples of differential equation, there is a place we say second derivative, or we say the squared y all over dx squared. So that is to say that this one involves second derivatives. We have the ones that involve one derivative. You can have maybe a differential equation with third, fourth, fifth derivatives. So the highest derivative in that differential equation is what we call the order of that differential equation. Hello. For instance, when you have something like dy all over dx equal to a sine x, what is the highest differential equation here, or what is the highest derivative here? The highest derivative is 1, that is dy all over dx. So we say that the order of this differential equation is 1. Now let me show you another one. We have d squared y all over dx squared plus 5 dy all over dx minus 6y. So you see here we have first derivative and we have second derivative here. So what is the highest derivative that we have here? Is what? 2. That is second derivative is involved, right? So we can simply say that the order of this differential equation is 2. The order is what? 2. You get it, right? Now let's go. I will still talk about this again so that you understand it very clearly, okay? Now let's go. What does it mean by degree? The degree of a differential equation is the degree of the highest differential coefficient which appears in the equation after removing radical signs and fraction. Now let me explain this. I know by now you have understood what we mean by order. Okay, now when you have the order and then you tell the order by the highest derivative, okay, good. Now when you have the highest derivative in a differential equation, what is the degree of that highest derivative? What is the degree? When you figure out the highest derivative in any differential equation, you can simply put it in brackets. So, does it have any power? If it is power 1, power 2, power 3, power 4, power 5, or exponential. Now, that exponential that is having, or that power, simply means the degree of that differential equation. So, you first of all know the highest derivative involved in that differential equation. So the highest derivative, what is the degree of that, or what is the power of that highest derivative? So the power is what we simply regard as the degree of a differential equation. Now, let me explain. Let me show you what I'm trying to say. For instance, you have something like d squared y all over dx squared in bracket squared plus dy all over dx plus 1 minus y equal to 0. Do you see this, right? Good. Now, what is the order of this differential equation? Now, the order we are talking about, what is the highest derivative? The highest derivative here is what? 2. That is to say, the order is 2. You get it, right? Good. Now, let's go back again. What is the highest derivative here? We said that the highest derivative is the squared y all over dx squared. Is that true? Now, what is the degree or what is the power of this highest derivative? You can see that the power is what? Is 2. So we simply say that the degree of this differential equation is what? 2. Now you have understood what we mean by order, and you've understood what we mean by what? Degree. All right. Now let me show you one more example in this degree. Okay. So we have something like dy all over dx in bracket squared plus 3 dy all over what? Dx equal to 0. Now look at this very clearly. We have dy all over dx in bracket squared plus 3 dy all over dx equal to 0. So here, what is the highest derivative? The highest derivative is what? 1. We'll simply say that the order of this differential equation is 1. Now, what is the highest derivative? We say that it is dy all over dx, right? Good. What is the power of this dy all over dx? We can see that we have 2 dy all over dx. So the first one is having power 2, and then the second one is having power 1. So what is the highest here? The highest is what? 2. So we simply say that the degree of this differential equation is 2. Okay, yes. Now let's see some few examples to tell the order and the degree, okay, based on the examples we have listed. But let's see it this way. We have example 1. We have dy all over dx equal to a sine x. What is the highest derivative? The highest derivative is dy all over dx, which is 1 derivative, okay? So simply say that this differential equation is having first order and then first degree. Okay, we have first order and first degree, or we say order 1, degree 1. Another example, we have d squared y all over dx squared plus 5 dy all over dx minus 6y is equal to cos x. Now we look at this. What is the highest derivative? The highest is d squared y all over dx squared, which is second derivative. So we say that this is a differential equation of second order. Now the highest derivative here now, what is the power of it? So that the power is what? 1. So the highest is d squared y all over dx squared. So what power is he having? He's having 1. So simply say that this differential equation is of second order and first degree. That is order 2, degree 1. Order 2, degree 1. Now let's say another example. We have d squared y all over dx squared in bracket squared plus x dy all over dx plus 1 minus y equal to 0. So when you look at this closely, you see that the highest derivative is d squared y all over dx squared. That is second derivative. And then the second derivative, what power is it having? We have what? 2. So you can simply say that this function, you can say that this differential equation is of second order, second degree. Second order, second degree. Now in the last example here, we have dy all over dx in bracket squared plus 3 dy all over dx equal to 0. So the highest order is 1. So the highest derivative is 1. And then the highest derivative is having power 2. So we say that this differential equation is of order 1, degree 2. Order 1, degree 2. Is that clear? Yes. In the next lesson, we are going to consider how to form differential equation. We simply say formation of differential equation. Then after that, we are going to talk about solution, how to solve differential equation. Please, if you are new to our channel, please subscribe, like and share our video. Stay blessed.